In this problem, canonical momentum of a particle is to be determined, whose Lagrangian is given as L equal to x dot y dot minus x square minus y square.
Lagrangian of the particle is given x dot y dot minus x square minus y square. So what is asked is momentum, canonical momentum PR, which is equal to dou L by dou R dot. So in polar coordinate it is asked, so xy is should be converted into r theta. So x equal to r cos theta, y equal to r sin theta. So x dot, we are having x dot and y dot in L. So x dot equal to r dot cos theta, keeping theta constant, differentiating r, and keeping r constant, differentiating theta. So we get here minus. Similarly, y dot equal to r dot sin theta plus r cos theta theta dot. So finding Lagrangian, L equal to x dot y dot minus, instead of x square plus y square we can put r square. So in multiplying x dot and y dot we get 4 terms. For multiplying these two first terms we get r dot square cos theta sin theta. First term and second term of this we get plus r dot r cos theta square theta dot. Second term of x dot and first term of y dot we get minus r dot sin square theta theta dot, and the second term of x dot and y dot we get plus r square sin theta cos theta theta dot square. So PR, momentum, canonical momentum, we get dou L by dou r dot, differentiating L with respect to r dot we get 2r cos theta sin theta. Here we get, differentiating this term, plus r cos square theta theta dot minus, differentiating the third term we get r sin theta theta dot. Fourth term we are not having r dot term, so 2 cos theta sin theta is equal to sin 2 theta, and cos square theta minus sin square theta is cos 2 theta. So this is the canonical momentum for the given Lagrangian.